Hi geometers, this is Ms. Backfish, and today we talked about a worksheet that was about the triangle sum theorem and the exterior angle theorem, and there was one problem on that worksheet, and it's this problem, number 19, that a lot of people struggled with, and the struggle is real, their struggle was really with information about isosceles triangles. So I just want to tell you a little bit about isosceles triangles to help you through problems like that and beyond. So first of all, it's worth learning how to spell I-S-O-S-C-E-L-E-S. Iso means same. It's basically about having same sides. Okay, so here's the deal. We all pretty much know that an isosceles triangle has two sides the same, or two sides congruent, as we like to say in geometry. But did you realize that an equilateral triangle also is an isosceles? Equilateral triangle, remember, has three sides the same. Technically, the definition of isosceles is such that as long as it has two, it counts. So an equilateral triangle is indeed isosceles. It's just that we don't usually worry about that because it's even more special. It's equilateral. So let's just assume we're talking about a garden variety isosceles that has only two sides that are the same. Did you know that those have parts? They're actual names for the parts of an isosceles triangle. So let's look at those. I have a pair of sides that are the same. Those are my legs. This is a leg, and this is a leg. Okay, so each of the two sides, or each of the congruent sides, is considered a leg. The side that is not congruent, that's the base. So here's the base over here. Now, I deliberately drew it this way because there's a lot of misconception that the idea of base always means on the bottom, but that's not necessarily the case in geometry. Your base for a triangle can be anywhere on the triangle. Your base for trapezoids can be anywhere on the trapezoid. So base doesn't necessarily mean bottom. In this case, it means the side that's not one of the two congruent sides. Then, once you've located the base, at either end of the base you have an angle. Those two angles, I'm going to do this, and let's do this for right now. Those two angles are called the base angles. So here's a base angle, and here's a base angle, and we have an announcement being made. So sorry about that, but we have two base angles in my isosceles triangle. So every isosceles triangle has two base angles. Then finally we have one more angle over here, and this angle is called the vertex angle. It's the one that's not like the others. Okay, so another announcement for your listening pleasure, I guess. Okay.
If you are not with a teacher, coach, or club sponsor,
I'm going to wait it out. I really am.
Gym lobby for pickup or to wait for your ride.
Okay.
Thank you.
So, vertex angle is the one angle that's different from the other two. Well, we haven't really said that yet. That was the next thing I was going to tell you. Sorry, spoiler alert. The next thing I was going to tell you is that it turns out there's a theorem, and it's called the isosceles base angles theorem. And it says the base angles of an isosceles triangle are always congruent. The two base angles of an isosceles triangle are always going to be congruent. So I'm going to do this just to bring that home. My two base angles are the same. They are always the same. Here's the why. Pretty much anytime you have a triangle, your biggest side is across from your biggest angle, and your smallest side is across from your smallest angle. If I take this triangle and I say, I'm going to take the two sides of this angle and I'm going to open it up more. If I open this up more, now this side has to be longer to bridge the gap. If I close it, now this side is going to be shorter so that it doesn't overlap. So the size of a side in a triangle is always associated with the size of the angle across from it. So if I have two sides that are the same, then the angle across from them, it makes sense that those would also be the same. So that's the situation. Now, here's how that affects us on this problem 19 that you had in your homework. What it looked like was this. Well, that's not the best drawing, but I'm still going to go with it. Okay, it had two triangles that are sort of joined at the hip here. I've changed my mind. I'm not going with it. It's too funky and lopsided looking. So let's go with this And there we go. I don't know how much better that is, but it's a little better. There we go. So we have two triangles, and they want this angle, and they tell me that this triangle over here is an isosceles triangle. But that's all I know about the triangle over here on the right. Then they tell me that this triangle over here is also an isosceles, and that this angle up here is 56 degrees. So the first thing I have to do is figure out where are my legs. These are my legs. This is the triangle I'm going to work with because it's the one I've got something to go on. So here are my legs. So this is the base. So the base angles are right here and here. That tells me that this is the vertex angle. If this is the vertex angle, then if I take that out of 180, then whatever's left has to be split equally between these two angles because they are base angles. So these two angles add up to 124, and each of them is the same. So if I divide 124 by 2, I get 62 degrees here and 62 degrees here. Now that enables me to come over to this triangle because I know that this 62-degree angle and this angle are a linear pair. So this angle should be the supplement of this 62 degrees. Okay, so 180 minus 62 degrees gives me 118 here, and then I can go through the process again over in this triangle, pretty much just ignoring that triangle on the left now. Now I only care about that triangle on the right. Here are the two sides that are the same. So the 118 is my vertex angle, and when I subtract 118 from 180, that gives me 62, and I divide it in two equal pieces. This will be 31, and this will be 31. And that's it.